Hello, grade 10 learners! Kumusta? I hope you are now in a good condition. I am Teacher Jonel and I am your grade 10 science teacher. Are you ready now in the fourth quarter? Great! Today, we'll be discovering another interesting topic in science. Together, we will be unraveling the concepts of Boyle's law. Fasten your seatbelt and let's hop in to our lesson objectives. A. Explain the relationship between the volume and pressure at constant temperature. B. Apply Boyle's law in a mathematical equations. And C. Cite practical applications of Boyle's law in our daily living. Before we begin, let's have some conversion and units. Now get your pen, calculator, and paper. Are you ready?
Now, what is the value in degrees Celsius when 373.2 Kelvin is given? If you answered 100 degrees Celsius, you are correct. Now let's proceed. Let us now recall some units and conversion factors for pressure. For the units of temperature, the Kelvin is the international standard unit of temperature. It is based on the properties of gases. Hence, there are no negative Kelvin temperature. The units of volume. The volume is the amount of space that a sample occupies.
And how are the pressure and volume related? To be able to answer this question, let's discuss first the characteristics of gases. Let's recall our definition of a gas. Can you determine the common characteristics of a gas?
We know that it is a phase of matter where atoms of the substance are in motion in a field of a container. Here are some characteristics of gases. Particles are points in random motion, and particles do not interact. When we sweep fluid, it flows. It continuously flows under an applied shear stress or external force. And gases have a very low densities. It has indefinite volume and it lots of empty space. Can you cite some example of gases? Here are the example of gases.
To describe gases, we need P as pressure of the container, and V as volume of the container, T as Kelvin temperature of a gas, and N as the number of moles in a container. Now, which shoes create the most pressure? The red heels or a rubber shoes?
If you answer the red heels, you are correct. Why? The pressure exerted on the ground while wearing a pointed heel will be more than that by a rubber shoes. This is because pressure is the force per unit area applied by an object. This means also that a force applied to a smaller area implies greater pressure than the one exerted on a larger area. Hence, it is not advisable to wear pointed heels. Now, how are the pressure and volume of the gas related? The example we had a while ago is a perfect demonstration of Boyle's law. If the temperature is constant, as the pressure of a gas increases, the volume decreases. Boyle's law was put forward by the Anglo-Irish chemist Robert Boyle in the year 1662. We have here in the graph the pressure-volume relationship. The graph shows that the pressure versus volume curve for a fixed amount of a gas keep at constant temperature. And this law can be expressed mathematically as follows.
Now for our sample problem. Are you ready to take a challenge? Now get your pen, calculator, and extra paper.
A balloon contains 30 liters of a helium gas at 103 kilopascal. What is the volume of the helium when the balloon rises to an altitude where the pressure is 25.0 kilopascal? Now let's analyze. We are going to list the knowns and the unknown. 2. Calculate, solve for the unknown. Isolate the final volume by dividing both sides by final pressures. Now substitute the known values for initial pressure, initial volume, and final pressure into the equation and solve. The final volume now is equals to 1.24 times 10 to the power of 2 liters. Now, can you cite some more examples of Boyle's law?
And that concludes our today's topic. Remember that Boyle's law at constant temperature, the pressure of a gas and the volume in a container are inversely proportional to each other, meaning when the pressure increases, the volume decreases. Hope that you've gained much learning in our discussion, and see you in our next video lesson. Till next time, Science Team learners!